we're going to be comparing areas and volumes of similar solids. We've done similar polygons before. So we had two different triangles. They are similar. That doesn't mean they're equal. That means they're proportional. Proportional meant it's the exact same shape, but one's going to be bigger than the other. Okay, so that's all we're looking at. We're looking at two solids that'll be similar. So one will be a small cube and one will be a big cube. So we're just going to be comparing, seeing what the difference is with their surface areas and volumes as well. So the other thing is we have similarity ratio. So another word for similarity ratio, the word that I used before, was the scale factor. Both same thing. So if you hear scale factor, you hear similarity ratio, they're talking about the same thing. So we're just talking about the fraction that compares their dimensions. So it compares their corresponding side lengths. So a little note in there, any two cubes are similar. A cube is actually when the length, width, and height are all the same. So if you had 2, 2, and 2, and then you had another bigger cube that's like 5, 5, and 5, the scale factor is 2/5. They're all the same size. So any two cubes are similar. And, any two spheres are similar because it's just a ball. So you're just going to have a ball with a radius and all the radii are the same. So if you have a ball that's 3 inches with a radius and then another ball with 6 inches as the radius, 3/6 is just going to give you a half. So all cubes are similar and all spheres are similar. I started this because this is the key point of today and tomorrow. So if you're looking for areas and volumes of similar solids, your similarity ratio or your scale factor is just A to B. So whatever fraction reduced you get, their surface areas are going to be squared. It's going to be the same numbers, but squared, and the volumes are cubed, just like the units. Area squared, volumes cubed, easy enough to remember. Okay, so I'll start you off with 3 easy problems, and then I'll get to the ones you'll most likely see more of. So are the two figures similar? You're saying yes or no. If so, state the scale factor or the similarity ratio, whichever they ask for. All you're doing is you're putting the corresponding parts on top of each other. So the 12 would go over the 40, the 24 over the 80, and the 18 over 60. So all you're doing is sticking that in your calculator, and if you hit math, enter, or if you're on Desmos and you hit the little fraction button right next to what you're doing, it's got like a little box over a box. It'll reduce it for you if you don't feel like thinking. So I did this ahead of time. All of these reduced to, I believe it was 3/10. So since all of them are equal, the two figures are similar. So you say yes, the scale factor is what they all equal. So my scale factor is 3/10. Sorry, other teachers are loud if you hear them in the background. All right, next, I wanted to give you a note as well. So you've got 40 over 8, and you've got 50 over 20. So if you reduce these, this is just 5 if you put it in your calculator. But if you need a ratio, it's the one time in math where you don't reduce something all the way because a ratio compares two numbers. So that would stay 5 over 1, and this would reduce to 5 over 2. So they are not equal, which means this is a no. Those are the easier ones. This one, that's Abby. This one says each are similar. So we already know they're similar. We're looking for the scale factor. And this is important. It says left to right. That means the picture on the left has to go on top. So whatever comes first goes on top. Whatever comes second, that goes on bottom. That's important. Sometimes they'll say figure A to B and they'll label them. It's not always left or right, but this one wants the left on top and the right on bottom. So you got your 200 over 160. You don't really need to do the 100 over 80 because it told me that they're already similar, but you can. If you reduce those, you're going to get 5/4. So there's your scale factor or your similarity ratio, whichever you're looking for. Then it says find the ratio of surface areas. So if I'm doing surface areas, that means I just have to square them. So if I just square both of those numbers, 25 over 16 is my surface area ratio. And if I cube them, that's going to give me my volume. Okay, and if you stick these in the calculator, they're not going to reduce. It'll always be like that with the squareds and the cubes. Okay. Next, find the similarity ratio or scale factor of 2 cubes. So I just threw 2 cubes on here, and they give you the volumes. Okay, so in this case, it doesn't matter which one goes on the top and which one goes on bottom because it doesn't say. So if it doesn't specify, it doesn't matter. So here's what I'm doing. I'm doing this, and since it is the volume, that means it's cubed. So to get the similarity ratio, I have to uncube it, which basically means take the cube root of it. Okay, I'm going to do the bottom and the top. So if you plug those in your calculator, and if you don't know where that is, in the calculators, you can go to math and then hit step 4. If you're looking for it on Desmos, you might have to pull up the scientific Desmos. I'm not sure if it's on the regular one. So the scientific, if you look up scientific Desmos, they'll definitely have the cube root on there. Cube root of 729 is 9, and the cube root of 1331 is 11. So there's my scale factor or my similarity ratio. And that's all they want. Okay, if you were looking for the surface area, it would be 81 over 121. You would just square that. Okay, what are we doing here? All right. Sorry, it's being crazy. So next, these are the ones you're going to see more likely. So it says the volume of the two are given. So these are the two volumes of two similar figures. The surface area of the smaller one is given. That is important that they told you that this is the smaller one because it's going to matter if you put it on top or bottom. So when you make your fraction out of these two, I'm just going to do the smaller one on top. If you do this smaller one on top, then when you make your other fraction, that one has to go on top. If you put it on bottom, same thing. 63 would have to go on the bottom. So if I do 27 over 64, like we did before, that's volume, so you have to uncube it. And that's going to give you 3/4. So when we're talking surface area, like I said, I kept the smaller on top. We're looking for the surface area, the bigger one on bottom. Now, it's not going to be equal to 3/4 because we're talking surface area. So for the surface area, you have to square them. So 3 squared is 9, 4 squared is 16. Then you just have to cross multiply. So if you do 63 times 16, you're going to get 1,008. 9 times x is 9x, and if you divide by 9, you're going to get 112. And that is meters squared because it's surface area. Okay, there it goes again, crazy. All right, here we go. So I put 2 of them on here, but we're just going to do number 21. I'll skip 22 for now. So it says there are 750 toothpicks in a regular size box. So this is filling up. The toothpicks are filling up the box, so this is actually going to be volume. Okay, if a jumbo box is made by doubling the dimensions, how many toothpicks will the jumbo box hold? So if I double dimensions, if you ever get confused about things, give them normal numbers. So if I have a box that is a 5 by 5 by 5, and then if I'm doubling them, it's going to be a 10 by 10 by 10. So your scale factor in that case, 5 over 10 would give you 1/2. So that's what happens if you double. So if the other box is doubled, your scale factor is just going to be 1/2, no matter what 2 numbers you pick. If you pick 10, double them and get 20, 10 over 20 is just going to give you 1/2. So that's my scale factor. So for my volume, I've got the volume of the small box, the one of the new one I'm looking for. I have to cube these. 1 cubed is still 1, and 2 cubed is 8. So now I'm going to cross multiply. 8 times 750, I did not put that, is 6,000. So it's going to end up holding 6,000 toothpicks. Okay. This one, the reason why I don't want to do this one is because you've got a 4 by 6. So you've got a cylinder that's got a 4-inch diameter and a 6-inch height, and it holds a pound of oatmeal. Then it says how much oatmeal will a similar 10-inch high. So you would have the 6 compared to the 10, which would be 3/5. And they didn't give me the diameter of the other one. So they gave me the 4-inch diameter, and then I have to find the diameter of the little one. This is why I don't want to do it, is 20 divided by 3 is an ugly decimal. It's, so it's going to give me like 6.3 repeating. So I don't want to do that one. So you'd have to do that to find the diameter and then compare. But I've got other problems down here for us to go over. So, all right, now the volumes of 2 similar containers are, Okay, so we're talking about volume. It says the surface area of the smaller, so this is going to be our surface area, and it's smaller, so I'm going to keep whichever one I want on top. So two similar containers, 115 and 67. So if I want to keep the smaller on top, that's how it's going to look. I need to, it says write the surface area of the larger container. So to get the regular, I need to cube root these, which those are not perfect cubes. So if I cube root 67, that's going to give me an ugly decimal. And if I cube root 115, and then what I'm going to do is I'm going to divide them. So I've got that, and then it says what's the surface area of the larger container. So in this case, I've got the 4.0615, and I've got the 4.8629. So these aren't real pretty. And even when I math enter them, they're not really changing for me. So it's just giving me a really big decimal. And then it just says what's the surface area of the larger container. So you just make sure that if I put the smaller one on top, I would be putting it equal to the same exact fraction. So it's equal to that, 46015 and 48629. Okay, so I'm going to times that by the 108. And then I'm going to divide it by the 4.06. So when I do that, I'm going to end up with 129, and round to the nearest tenth is 3. So what is the surface area of the larger container? Oops, squared, because it's surface area. And there you go. So the numbers aren't pretty, but all I did was I cross multiplied just like normal. Okay, and then finally, I got two more for you. Okay, so lateral areas of two cans. Here are my two lateral areas. So those are squared, which means you have to unsquare them. I'm not going to mess with the lateral areas. So I've got cylinder. I didn't even write what lateral area is. So let's just call this surface areas, because I didn't even write the formula for lateral area down. So let's just call them surface area for now, for the sake of time. So I've got 1019 and 425, and I need to unsquare them. So that's how it's going to be. I've got the square root of the 1019. And I've got, which isn't nice, of course, square root of the 425. So it's going to be about 31.9218 and 20.6155. Okay, then we've got the volume. So I've got to, if I'm going to talk about this, I'm going to have to cube it to be able to get that. Of course, there's a message. So the
Mr. Coffey, please report to the office. Mr. Coffey, thank you.
So I put, if you notice, I put the small one on the bottom. So you have to be careful with that. When you do that, you have to stay consistent. So if I'm looking for the big one, I got the big one on top. So I'm going to have to take that and I'm going to have to cube it. So that 20 cubed is this, 0.5995. And on top, I'm going to take that and cube it. And this is going to give me 32,528.2932. Okay, so I'm just leaving those numbers in my calculator to make life a little bit easier. So I'm going to times it by the 1157 and then divide it by the 87 or 8,000. So that's going to end up being, for my volume of the larger can, if I round to the nearest tenth, 4,295.5. Okay, and that'll be centimeters cubed because it's volume. So that's all you're really doing. We're just messing with these numbers. You just have to remember that if you're dealing with the volume, you got to cube it. And if you're dealing with the surface area, you got to square it. So the last one, I've got 12 pencils in a regular size box. So this is 12 pencils fitting inside of them. So that's my volume. jumbo box is made by tripling the dimensions of the regular box. So if you had 5, 5, and 5, if you triple them, tripling them is going to give you 15. So it's going to be 1 to 3 for your scale factor. And then how many pencils would the jumbo box hold? So this is the regular size. So if we're talking volume, you have to cube it. So cubing 1 is still 1, cubing 3 is 27. So I have to do 12 times 27, and that's going to give me about 324 pencils. Okay, now, just in case you want the extra problems, like if you're working on the problems for the homework and you don't get it, something along those lines, if you're not sure if you're right, I've got some problems here. So you can kind of go through these problems if you want to. 19 was the one I did in the notes, and then here are your answers. So if you need to practice any, you need any extra work, there it is.